All right, guys. So now what we're going to look at is, like previously, if we looked at how we can solve a system of equations and use elimination to do that. Well, eventually what we want to be able to do is we want to be able to use something called matrices to help us solve a system of equation. It makes things a lot easier. In order for us to do that first, though, is we kind of have to be able to identify what a matrix is. Okay. A matrix is a rectangular array of numbers. A plural of matrix, a matrix is matrices. So like if I look here, I have, this is a rectangular array of numbers. I got 4, 8, -1, 2, 0, 2.5. It's a way to organize numbers. And if you were to take something called linear algebra in college, you will deal a lot with matrices. So in this case, when we identify what the size of the matrix is, we will always go by rows versus columns. So like if I look at this situation, I have 2 rows and then I have 3 columns. So the dimensions of this would be a 2 by 3 matrix. So if I look at this example, well, in this case, row-wise, I have 2. Column-wise, I have 2. So this matrix would be a 2 by 2 matrix. Now, if I look at the next one over, how many rows do I have? 1, 2, 3. So this would be a 3 by 2 matrix. Okay. In this next one, I have 1 row, and I have 4 in a column. So this would be a 1 by 4 matrix. Now, there are certain things that are true. Okay. Like if I look at a matrix, I can always multiply it by some sort of value. This 3 in this case is I'm taking 3 times matrix A. This 3 is considered to be something called a scalar. Or you're doing something called scalar multiplication. So if I wanted to figure out what 3A is, I can take 3 times all of these values. 3 times 4 times 2, -2. We got 0, 9, and we got 12. So I can distribute, kind of like think of this as being parentheses, all the way through. So I could take 3 times 4, well that's 12. 3 times 2 is 6. 3 times -2 is -6. 3 times 0 is 0. 3 times 9 is 27. And 3 times 12 is 36. So this matrix, after I take 3 times all of matrix A, is I get 12, 6, -6, 0, 27, 36. Okay? So like if I look here, I want to figure out what would matrix B be. If I took 4 times B, I get this answer of -8, 12, 2, and 20. Well, how can I find that? Well, I could divide it by 4. So I could take all of these things and divide it by 4 to figure out what matrix B is. So if I wanted to know what matrix B is, -8 divided by 4 is -2. 12 divided by 4 is 3. 2 divided by 4 is 1/2. 20 divided by 4 is 5. So matrix B turned out to be this. Okay? Now, I can also not only multiply it by some sort of scalar, but I can also combine things together. But in order for me to do this, in order for me to add matrix A and matrix B together, they have to have the same dimensions. Well, this is a 2 by 2. This is a 2 by 2. So I can add these 2 matrices together. Well, think about, we're just combining like terms. We're taking things that are in a like position. So I'm going to take 3 and 3 and add them together. I can take 7 plus 3 and add those together. 2 plus 0, add those together. And 0 plus 9 and add those together. And when I do that, I get 6, I get 10, I get 2, and then I get 9. So when I combine matrix A and matrix B together, I get 6, 10, 2, 9. Well, let's kind of put this all together, okay? Let's do a multiple thing, all right? Like if I want to take, first we want to figure out what the dimensions of A are. So looks like it has 2 rows, 2 columns, so it's 2 by 2. If I look at B, it has 2 rows, 1, 2, 3, 4 columns, so it's a 2 by 4. C, well, why don't you try this, and then you can pause the video if you want to know what the dimensions are, but I think it turns out to be 2 by 4, and then D turns out to be 2 by 2. So if I look at A and D, I am combining this matrix and this matrix together. So I'm taking 1 plus 12. I'm taking 7 plus 5. I'm taking -2 plus -1. And I'm taking 9 and 2, adding them together. So it looks like I get 13, 12, -3, and 11. Okay. Well, now for D, what I'm doing is I'm taking 4 times matrix D. So it's 12, 5, -1, and 2. So I get 48, 20, -4, and +8. Okay. That would be what 4D is. Now, this last one is asking me to find out what B plus D is. Well, in this case, it's a 2x4 and it's a 2x2. If I look at these two matrices, are they the same size? And we would say no, because there's 2 more columns in matrix B than there are in D. So in this case, because they're not the same size, we would say there's no solution. So I'm going to ask you guys, before class tomorrow or whenever we see each other next and we talk about this, I'm going to ask you guys to try these questions on page 9. Okay, try this, and we will talk about them when I see you next.